So this is my first experience with the VFD. When I started knife making, I had a 1x42 and thought that was okay. Then I said, well, maybe I'll build a 2x72. So I built this 2x72 from USA Knife Maker Plans, this yellow part, and that was okay. And then later I added my own modifications that made it more accurate and less sloppy. The materials called out in USA Knife Maker Plans were really sloppy. Found these aluminum tubes and the bars that fit inside of them. Those things are amazingly accurate. And so I ran that. I had the 5 horsepower air compressor motor on there with step drive pulleys and thought, nobody needs anything more than that. And then I decided to try this little spindle motor with the VFD drive on it in preparation for a new sander that I have. I'll show that in a moment. And now I'm hooked on the VFD. So if you don't want to spend the money on a VFD, don't try one, because they are really nice. And I didn't think that I would be saying that, but they're really nice. And this one is super nice. It's a 3 horsepower, 3-phase, 24,000 RPM motor. Runs a 1.1 inch diameter custom wheel that I designed and built. It will turn the belt at 7,000 surface feet per minute, which is what's required for, what's recommended for operating these 3M Cubitrons. They recommend 7,000 to 8,000 surface feet per minute on these with heavy pressure. I can provide the 7,000 surface feet per minute from this little motor, and I use the multi-guide in the front to provide the heavy pressure under control. Makes for super fast, super clean grinding. I mean, just check out some of my other videos. You can see what it does. Anyway, I was going to take this motor off and put it onto that other frame once I finished and put the big motor back over here. It didn't happen. This motor is staying here. I love it. It's going to stay here. The big motor is going back into storage. My sander just went from this big to this big by getting rid of that motor and all the heavy drive assembly that was there. So what I did was I bought another spindle motor setup. You can buy these on eBay. $350 delivered is how much this one cost me. Comes with the VFD drive. It's got the rheostat knob on it. If you're going to buy one of these and try this, I recommend the rheostat knob, the first one I bought. I bought a motor and the drive only, and I didn't get the rheostat drive model. It's a little bit more, like $20 or so for this button. Get the button. You won't be disappointed. Now this is, you can see from the pictures that it's air cooled, or it's air cooled. You got a fan that runs in there. Now you're operating in a heavy metal or electrically conductive dust environment by grinding knife dust all over the place. And so you want to take provisions. A lot of guys will put these things in those NEMA wash down VFDs, and those are nice. I don't wash mine down with water. I just need to protect it from the dust, and so what I've done in my case is I've wrapped around an air filter from the house. I cut it up and wrapped it around and then taped it so that it allows the air to flow through but keeps the electrically conductive metal dust out. It's been doing good so far. It's mounted right on my machine, right close to all the dust. It hasn't had any problems. So what else comes in here? You get some water hose because the motor is liquid cooled. You get a little water pump for this in this kit. Alright, this is a 220 volt water pump, which works out perfect because it's a 220 volt motor. What I will do here is I'll cut the plug, strip it off, and plug it in and connect this into the VFD drive on some of the posts in there so that when the VFD is powered, the motor is running. That way you don't have to worry about turning this on and off by itself. Anytime you flip the power onto your VFD drive, the water pump will kick on and the water will start flowing to your motor. get a motor mount here, or motor clamp. What I've been doing is I'll drill this and mount it to a plate. You can see that over there. Let's see, there is an extra nut here. Not quite sure what that is. I haven't seen one of these before. It's a nut. Got man fingernails. I can't open this thing. Alright, looks like it's just a spare nut. That's nice. The motor came with one on it, and so now we've got a spare. When we get down to this piece, this is the little powerhouse. Alright, so that's the motor. You got a 4-pin plug on the back. Got your water in and outs. And then your drive on the front end. These things aren't very heavy. That's about 12 to 15 pounds. I'll weigh it later to make sure. I think it's about 15. So you spin these off. Got your collets. Take a quick peek here. My son was out here helping me. Oh, here we go. In the kit, you get all of these collets. Come in the kit as well for that $350. Which is way more than you need way more than I need for this application. Here's number 5, 2, 3, 4. Trying to find 1/8. They've got them in metric. These are in metric, and these are in inches. 13, 9, 7. Alright. I am looking for that one. Alright, this is the 12. Should be the 12 millimeter. Exactly what it is. Could do this on a table, I suppose. But I'm already down here. Alright. So all those, I don't use them myself. So we're going to do, what I've got, the way I've got the design set up is I use the 12 millimeter. And this wrench was included. So you get a collet nut wrench on there, and then you hold it right there. So the way this drive works, you have the motor, and then that chucks into the collet, just like it's a router bit on the spindle. Alright, and so that's the basic drive unit. So this isn't much bigger than an actual router would be. And so it allows, what this small design allows the motor to run through its full RPM range. When I designed the drive system, I wanted the target of 7,000 surface feet per minute on the belt. This will give you that when this is running at 24,000 RPM. That way you're not lugging the motor, you're not putting a big drive wheel on there and then running the motor slow at half speed, trying to get it to make the belt speed you want while the motor's, lugging and pulling. The motor is allowed to run like a spindle motor. And that, to me, was one of the keys of success, was let the motor run like it's designed to run. It's designed to run fast, and that's the way its power is developed, is by running fast, and not by lugging along like a conventional motor, 150 RPMs or 3450 RPM, that kind of thing, where they run slower and develop a lot more torque. Um, on my applications in the the 2x72 belt sander, and the way I grind, I don't need a ton of torque on the low end because I just need the belt to move. That's where I'm doing my delicate work. I'm not putting very much pressure on the belts. This has been beautiful for that. It's got lots of torque, excessive torque on the bottom end for everything that I've needed to do up to now. I haven't done everything yet, but the things that I haven't done, I don't anticipate that they'll cause any trouble with the performance of this on the low end. Top end, I have ground 30 blanks so far on the other machine. The motor is amazing at the top end. It is screaming, and it just rips off the metal. Like I said before, those belts require a lot of power to run them at that speed, or they require a lot of speed to make the belts operate good. And I've had some guys that run these that bought my guide, and they were running it slow, 4,000 or 5,000 surface feet per minute on there, and they're starting to burn their blanks, and the belt's not cutting. And it took me a little while to figure out, and I said, well, how fast are you running? And they're like, we're running about 80% on our machine. And I'm like, well, crank that thing to 100% and put in some pressure and fracture the grit on your belt so that you get new sharp edges. And I haven't heard any complaints back from them since then. So, it's just the whole industry, well, and I say the whole industry, it seems like the majority of the industry doesn't grind near as fast as I grind. There are a few people that do, and I happened to see one of those guys, N-Trek knives, when I was designing my first sander, and I said I wanted to grind like that, and I'm glad I did. It is awesome when you're grinding fast, when you have the capability to grind fast when you need to or want to. Now, this is a small motor, small bearings. It's not going to take a lot of side load. Now, when the belt tensions on here, it puts a lot of load onto these bearings in here. And I didn't think this little motor would handle it. I'm pretty sure it won't handle it. It's not designed for that. It's not a big frame, not big bearings, not designed for carrying a heavy load. So what I've done is I've trapped, and you can see that I've got bearings installed on here, and I have a mechanism or a mount system I designed that holds this wheel onto a plate so that the wheel, all the belt tensioning of the wheel stays on these bearings only. It doesn't transmit anything into this shaft or into these bearings. The motor is there only to provide rotational force. It doesn't provide any stability or any rigidity to the wheel. It only turns the wheel. And by doing that, my hope is, and the design idea was, that it would preserve this motor as long as possible by not loading it up. So then this motor can just run as a router. These bearings can obviously take some side load because as a router is passing into material, there is a tiny side load, at least a tiny side load applied to it in the direction of travel. And also you have that really high frequency vibration that comes as each little cutting edge of a router impacts the material. And so the bearings aren't completely useless. They do have some strength in them for those purposes, but I'm not carrying any load in those. So anyway, this is the new sander frame. This is what it's looking like at the moment. There's going to be a few modifications. I have a handle ready to put here. This is going to be your tracking system up there. I'll put a tensioning mechanism in here. I have two different ideas. I'll try both of them and see which one is better. Let's see. The drive motor is going to go in about this area. See how small that is? That's going to be nice. In here will be like your platen. I was going to use this for the guide, to, because that's the way I use it currently. I use a two slotted system on my current machine. I'm thinking about not using that. I'm thinking about just using a single, and then I do make an adapter. I've made it for KMG machines that goes actually on your bar here to hold the guide. So I think I might go to I might go to that. I'm going to test it out. Definitely I'll test it out. But what I'm planning to do, or to test out, is use this bottom guide on the rear side as the motor mount, so I can make a modular motor mount. I've got an idea, and I'm going to try to make it happen, is to make this a takedown machine so it can become portable. This tiny little drive unit and a tiny little frame and all the power of one of the big, and all the power of a full-size machine. I think this will be something that will be interesting to try. Also, this machine is going to be capable of going horizontal, and the motor will rotate with it. And that's one of the things that I need to change. Is my initial design is I built this a little too low. I have 10 sets of parts made for these, so I have lots of parts to practice with. Thanks for watching. Take care.